Hey, what's up? It's Jake, and now we're going to move into a section on numbers. So we're going to start by going into the built-in data types for numbers. I'm going to get into an interactive shell here. Now, Python was created by someone who had a master's degree in computer science and mathematics, so it stands to reason that it's pretty extendable in the area of mathematics, and it turns out that's actually true. It's also worth noting that numbers are immutable objects. They um, have an unlimited range. Really, it's just the limit of how much memory you have on your computer. So if you do some crazy calculation that just goes and goes and goes and goes and goes and never stops, it's possible you could go into your resource monitor, whatever you use, and watch your memory just start slowly filling up. This is very evident when you start doing calculations with prime numbers. So be careful that you don't crash your own computer. I don't recommend doing these types of things unless you really know what you're doing. Um, so let's get into it. So as you learned before, numbers are expressed as integers, and integers can be positive, they can be negative, or they can be zero, and they support all the basic mathematical operations that you would expect, and I'll go ahead and show you that now. So I'm going to set a to the value of 14 and b to 3. And I can do addition. A plus b is 17. I could do a minus b, do subtraction. I could do a times b. And you don't need to do these spaces. I do them, a times b like this would work just fine too. I just don't think it looks as nice. And readability matters. So Zen of Python. And if you ever, by the way, didn't find that Easter egg, you can do import this, and it will show you the Zen of Python. These are the guidelines I tried to follow, and readability counts, sorry, is what I was going for. So you could also do a divided by b, which is 4.66 repeating. And then there's this other thing where there's two divided by signs, and it's not a divided by b. It's a divided by b, but it uses uh, integer division or something called floor division, where it will just truncate the end of that number and return the value without the remainder, right? Basically. And speaking of remainders, if you want just the remainder, you can do something called a modulo b. In this case, if I did 14 divided by 3, well, 3 only goes into it 4 times. 3 times 4 would be 12, and you'd have 2 left over. So a modulo b gives you the remainder, which is 2. And in some cases, having the modulo is very useful. So just know that we call remainders modulo, and you use the percent sign to find that. And then there's exponents, and we do 2 stars or asterisks or multiply symbols to say a to the b power or 14 to the third power. So that would be the same thing as 14 times 14 times 14. Um, and that's the basic arithmetic or mathematical operations, not arithmetic, the mathematical operations that we would use in Python. So then there's a little bit more complicated stuff. That stuff should be pretty easy to understand. We will go over the integer division or floor division here in a sec, because I want to show you what happens when you start using negative numbers. So let's take a look at what happens when we do negative numbers. So if I say 4 divided by 7, we get 1.75. Okay, if I say 4 divided by 7 using integer division, what do you think is going to be the value? Well, if you remember, I said it's going to truncate the end of the number and just return the integer. It's going to return 1. You don't need to know necessarily the application of this yet, but just know that this is extremely important, especially in the finance world, and caused a whole bunch of problems in the economy a couple decades ago. So then you have negative numbers. So if I say negative 7 divided by 4, we see it's negative 1.75. And that's to be expected, right? So what do you think happens when we do floor division of negative 7 divided by 4? What do you think that number would be? Well, we know that negative 7 divided by 4 is negative 1.75, and it's just going to truncate the end of that and then round it down, right, to somewhere. And you'll see that the answer is negative 2. And the best way I can describe this is that when it truncates the decimals or the remainder and just goes with the integer, which in this case would have been negative 1, when it rounds it, it actually rounds it toward 0, right? Like down. So, well, I shouldn't say toward 0. Like it goes down. So in this case, if you truncate the 0.75 and it rounds it down, if you were to look at it on a number line, it's going to go from 0 to negative 1.7, well, from your view, negative 1.75, truncate the 0.75 and round down. So it's actually going to go down to negative 2. Whereas when we went on the positive direction, it truncated 1.75 and went down to 1. So a little tricky kind of concept there, but the behavior is different, right? It's an interesting example. If you were expecting negative 1 on this side, that's fine. Don't feel bad. This is just the way that Python works. Integer division is always rounded toward negative infinity, so it'll always go down. So if you have a negative 1.75, it's going to go down. If you had negative 3.75, it could go down to 4. If you had 3.75, it could go down to 3, and so on and so forth. Instead of flooring, if you want to truncate the number to an integer, you could do that using int. So if I did, what is the int of 1.75? It will just return 1. And if I wanted the int of negative 1.75, and this is a behavior that you actually wanted, you didn't want it to floor to negative 2, you could use int and it would do the same thing and just drop the remainder and give you the actual integer that's from the original value. So this will go down toward 0, by the way. So when I said it goes towards 0, I was thinking of this. So when you use int and you think of the number line, whatever you convert with the integer built-in function, it's always going to take a negative number and go towards 0, and it's going to take a positive number and go towards 0, which is why int 1.75 goes toward 1, and int negative 1.75 goes toward negative 1. Hopefully that makes sense. Um, it's worth noting that the power operator also has a built-in function with a really, really cool function called pow, right? So if I wanted to say pow 10 3, that's how I would do that. And that's just saying, I want you to take 10 to the power of 3. And you could write it like that, or you could write it like this. It's up to you how you want to do that. You can do it with negative numbers and say pow 10 negative 3, or you could say 10 times negative 3, like that, and get the same thing. And again, it's whatever you want. There's also an operator to calculate the remainder in division, which I said was modulo, right? Um, it's represented with a percent symbol, right? But you just want to make sure you understand the concept. If I did 10 mod 3, as we say, we would say, you could say 10 modulo 3, but it's more common to say 10 mod 3 or 10 mod 4. 4 goes into 10 twice, right, with 2 left over. So there's our 2 left over. And that's how mod works. The Pow function allows a third argument if you want to perform modular exponentiation. Exponentiation, yeah. The form with 3 arguments accepts a negative exponent in the case where you want like the base is relatively prime to the modulus. So that's an option that you can do. And the result of that is something called modular multiplicative inverse of the base, or a suitable power that whatever the exponent's great if it's not -1. So the modulo is the third argument, basically. So let me show you what that looks like. And if your brain is going nuts right now, that's okay. Feel free to just pause, take a sip of water, keep going, take the video back or whatever. So if I said pow 123 to the 4, that's saying I want to know what 123 to the 4th power is. If I did what is pow 123 comma 4 comma 100, you'll get 41. What the heck does that mean? So if you were to take this original number 228886641 and you were to divide this by 100, you would get this number with a decimal remainder of 41, right? So this is saying I want to go this to this power, and if I were to do modulo 100 or mod 100, I would have a remainder of 41. Okay, let's try it with a smaller number. So if I said pow 37, I want to take 37 to the negative first power mod 43. This would be the modular inverse of 37 mod 43. Let that sit in for a second. And if you want to prove the above is correct, I could say, okay, well, 7 then times 37 mod 43 comes out to 1. And that's how you know that it's correct. So one nice feature that Python came up with a while back was the ability to add underscores with number literals. So like between digits or base specifiers or whatever. The purpose was to help make some numbers more readable. So instead of going, let's say I wanted to say that n equals 1024, and you don't like the way that that looks, and you would rather it look like n 1 comma 024, like you would see it in a spreadsheet or whatever. Well, Python doesn't understand what that means, but it does understand if you said underscore 024. It understands that as a separator, right? So if I did that and I returned n, it would just return the number without all of that. But it does make it easier to read, which is nice, especially when you're dealing with billions or trillions, or even sometimes millions or hundreds of millions. It does make it easier to read, to be able to kind of go, how many commas does this have, to figure out what that is. And so like if you took a giant number, like hex n equals 0x underscore 4 underscore 0 underscore 0. And then I said, give me back hex n. It's 1024. So there's ways to do it with hexadecimal notation. There's ways to do it with decimal notation. However you want to do it. But just know that the underscore can be used with integers as a separator to make it a little easier to read. And I appreciate that. But it's not used a lot, but it's definitely something that I think that um, can help if you're reading the numbers here and not with them converted into like a UI or a spreadsheet or something like that where they're automatically added with the commas are automatically added. So that's it for numbers. If you have any questions, let me know. And if not, then we'll move on to our next data type.